All right, this week we're going to look at rationalizing denominators. Basically, when we write our answers out to any of our problems with our radicals, we don't want to have a radical in the denominator of a fraction. So, kind of in general, what do? If I want to get rid of the square root of b on the bottom, I can do a few things, but the best thing is to multiply by 1. And the reason to multiply by 1 is it doesn't change anything. I'm going to be a little creative, though. I'm not going to write the number 1. I'm going to write the number 1 in a different way. I'm going to write it as the square root of b over the square root of b. So that guy's still 1, so I'm not changing anything. I'm just changing how it looks. It's kind of getting dressed up for Halloween here. So on top, I have a times the square root of b. And on the bottom, I have the square root of b times the square root of b, which is the square root of b squared. And what is the square root of b squared? Well, it is just b. So a divided by the square root of b is exactly the same thing as a square roots of b over b. Now, we're going to look at some problems with numbers because I know for a lot of you, looking at it with variables only, don't really understand what's going on. So let's take a look at a problem. So first we're going to look at 5 over the square root of 11. So I'm going to multiply by 1, but I got to be creative here, and I got to choose my 1 carefully. So I'm going to choose to do the square root of 11 over the square root of 11. I'm just multiplying by the radical on the top and bottom. So up top I have 5 times the square root of 11, or 5 square roots of 11. And on the bottom I have the square root of 11 times the square root of 11. And I'm just going to kind of blow this. Well, that's the square root of 11 squared, which is just 11. And that's my answer. Now, if you can simplify further, you would, and we are going to do a few like that. All right. So 3 over the square root of 6. So same process. I'm going to multiply by 1 to get rid of that radical. So this time I'm going to pick the square root of 6 over the square root of 6. So when I multiply up top, I have 3 square roots of 6 over 6. So hopefully you're all starting to realize when you multiply a square root by itself, you basically get rid of your radical there because this is the square root of 6 squared. All right. But if I look at 3 square roots of 6 over 6, I'm like, I can simplify that because if I look at 3 over 6, that is just 1/2. So I have the square root of 6 over 2 because I can take the 3 out of both of those, leaving a 1/2. You always have to simplify your answers. All right. Now, sometimes you get a question and it looks just like what we've been doing. We have a number over a radical. But if you look carefully, you should recognize square root of 16. Oh, that's a perfect square. This really just says 12 over 4. Well, 12 divided by 4 is 3. Now, if you went through the process and you said, okay, I'm going to multiply by the square root of 16 over the square root of 16, you could absolutely do that. And what happens is you get 12 square roots of 16 over 16, which is really 12 times 4 over 16, which is 48 over 16, which is still 3. So you see, if you can recognize you have a perfect square before you start, you can save yourself trouble. Just immediately take that square root of 16, make it a 4, and simplify. All right, now this one looks different. It's not. It's the same idea. I'm going to multiply by 1, and I'm specifically going to use the square root of 5 over the square root of 5. So I have 3 times the square root of 5 up top. Now on the bottom, I need to be careful. I have 2 times, and remember, this right here, square root of 5 times square root of 5 is just 5. So 3 square roots of 5 over 2 times 5 is 10. All right, so on this one, multiply by 1, square root of 5 over square root of 5. Now, Up top, 5 square roots of 5 over 2 times. Remember, that together is a 5. Your 5's cancel. Square root of 5 over 2. Now, I do want to show you some shortcuts because that's doing it algebraically, which for some of you, you're going to need to do it that way because the shortcut's not going to make sense for you necessarily. But for those of you that the shortcut makes sense, I want you to look at this slightly differently. So this is the same problem. I'm just going to rewrite it next to it. 5 over the square root of 11. What I like to do is say everything that's not in a radical, write it exactly where it is. So right now I just have a 5 not in the radical. Anything that is in a radical, you bring the whole radical to the top, square root of 11, and then you bring just the radicand to the bottom, and you have your answer. Now, if this part can be simplified, you would simplify it. But I want you to notice it's the same answer. So I'm going to do it with this one that simplifies right here. So we started out with 3 over the square root of 6. So for the shortcut, anything that's not in a radical, go ahead and write it down. Anything that is in the radical, bring it to the top and bring just the radicand straight over. And then simplify if you can. Well, 3 over 6 is a half, so I have the square root of 6 over 2. Now, one that's not going to come up because I didn't do one like that, so I'm going to make one off to the side, is what if you have something like 3 square roots of 2 over the square root of 5? Well, if we follow the shortcut, it says take everything that's not in a radical, write it down. And then it says bring your radicals to the top. Well, this radical's already up top, so he just stays put. This entire radical comes up top, and then just the radicand, the inside, comes over. We just have to simplify. So we have 3 square roots. Remember, if there are 2 square roots, we can multiply their insides together, 10 over 5. And there is our answer. All right, make sure that you stay caught up on your assignments. Post everything to Edsby as you need to. And don't forget, you will have a quiz later in the week.